8206. Oxygen and acetylene cylinders are made of A. Seamless aluminum. B. Steel. C. Bronze. The correct answer is B. Oxygen and acetylene cylinders are high-pressure containers used for storing and transporting gases used in various industrial processes, including welding, cutting, and brazing. These cylinders need to withstand the high pressures generated by the gases they contain, so they are typically made of strong and durable materials. Steel is the most common material used for oxygen and acetylene cylinders due to its strength, durability, and ability to withstand high-pressure conditions. Steel cylinders are designed and manufactured to meet strict safety standards and regulations to ensure the safe storage and transport of compressed gases. While other materials such as aluminum or composite materials are used for some specialized applications or alternative gas storage solutions, traditional oxygen and acetylene cylinders are predominantly made of steel due to its excellent properties for this purpose. 8206-2. High-pressure cylinders used to transport and store acetylene must A. Be pressure-tested to 3000 psi. B. Be green in color. C. Contain acetone. The correct answer is C. Acetylene is a highly flammable gas that is commonly used in welding and cutting operations. To safely store and transport acetylene, specialized cylinders are used. These cylinders are designed with specific safety features to ensure the stability and integrity of the gas. One important feature of acetylene cylinders is the presence of a porous material, such as calcium silicate or asbestos, which is saturated with acetone. Acetone serves as a solvent for acetylene and helps to stabilize the gas inside the cylinder. The porous material provides a large surface area for the acetone to come into contact with the acetylene, promoting dissolution and preventing the formation of acetylene crystals, which can be highly explosive. Therefore, high-pressure cylinders used for acetylene must contain acetone to enhance the safety and stability of the gas during storage and transportation. This is an important requirement to minimize the risk of accidents associated with acetylene handling. 8207. When a butt-welded joint is visually inspected for penetration, the penetration should be A. 50% of the thickness of the base metal. B. 100% of the thickness of the base metal. C. 75% of the thickness of the base metal. The correct answer is B. When visually inspecting a butt-welded joint for penetration, the goal is to ensure that the weld has fully penetrated the thickness of the base metal. This means that the weld should extend throughout the entire thickness of the base metal, creating a strong and reliable joint. Incomplete penetration, such as option A, 50% of the thickness, or option C, 75% of the thickness, would indicate that the weld has not fully fused with the base metal, resulting in a weaker joint. In such cases, the weld may not have sufficient strength and may be more prone to failure under stress. Therefore, when visually inspecting a butt-welded joint, it is essential to verify that the penetration is 100% of the thickness of the base metal to ensure a sound and durable weld. 8208. Annealing of aluminum. A. Increases the tensile strength. B. Makes the material brittle. C. Removes stresses caused by forming. The correct answer is C. Annealing of aluminum involves heating the material to a specific temperature and then slowly cooling it. The purpose of annealing is to relieve internal stresses that may have been induced during the forming or shaping process. When aluminum is subjected to processes like bending, rolling, or machining, internal stresses can accumulate, which can affect the material's properties and performance. By annealing the aluminum, the internal stresses are effectively relieved, and the material returns to a more stable and balanced state. This process helps to reduce the risk of distortion, warping, or cracking in the aluminum component. Additionally, annealing can improve the formability and workability of the material, making it easier to shape or manipulate. 8209. Edge notching is generally recommended in butt welding above a certain thickness of aluminum because it A. helps hold the metal in alignment during welding. B. aids in the removal or penetration of oxides on the metal surface. C. aids in getting full penetration of the metal and prevents local distortion. Point 13-1. The correct answer is C. Edge notching is a technique commonly used in butt welding of thick aluminum plates. It involves creating a V-groove or U-groove along the edges of the plates to be welded. This groove provides several advantages in the welding process. Firstly, the edge notching helps to ensure full penetration of the weld. By creating a V-shaped or U-shaped groove, the weld pool can penetrate deeper into the joint, resulting in a stronger and more reliable weld. This is particularly important for thick aluminum plates where achieving full penetration can be challenging without edge preparation. Secondly, the edge notching helps to prevent local distortion during welding. Aluminum has a high thermal conductivity, and when it is heated during welding, it tends to expand and contract rapidly. This can lead to distortion or warping of the welded joint. By creating a groove, the heat is distributed more evenly, reducing the concentration of heat in one area and minimizing the potential for distortion.